In this section, we're going to look at one more technique for solving quadratic equations, and it actually involves a formula, the quadratic formula. The formula is derived by applying this method of completing the square to the general form of the quadratic equation. Now, the general form of the quadratic equation is a form in which we're letting letters stand for these coefficients and this constant. And then with this general form, we apply the idea of completing the square, and we come to the point where we have a formula for finding the value of x in the quadratic equation. And we can apply this formula then to all quadratic equations. This is called the quadratic formula, and here is how it's derived. To derive the quadratic formula, we begin with the general form of the quadratic equation. Now we're going to apply the method of completing the square. Our first thought is perhaps to change out our constant term. That is, let's get rid of the constant term on the left side of our equation. We'll subtract c on both sides. Now, the method of completing the square only works when the leading coefficient is 1. So to clear that leading coefficient of a, we'll divide throughout by a. Now, we get the cancellation as expected in our first term, so we'll bring down the x squared. Now, bx over a we'll write as b over a times x to show the distinct coefficient of the x. And the negative c over a we'll think of as negative c over a. Now we're ready to complete the square. Now remember what our prescription was. It was to take the coefficient of that middle term, the coefficient of x, and take half of it, and then square the result. So here we have b over a times 1/2, quantity squared. Now b over a times 1/2 is b over 2a. And b over 2a all squared is b squared over 4a squared. Now that's the amount we'll add to both sides of our equation. Now we're ready to factor on the left. Now remember what that amount was that we squared. We squared b over 2a. So the factoring is particularly easy on the left side. On the right, we want to do a collection of our two fractions. Our first thought, though, is perhaps to put the fractions in another order, just listing the positive fraction first, or the one with a plus sign before it, before the other one. And now we're ready to find a common denominator. Now notice the common denominator is 4a squared, so we'll multiply in the second fraction by 4a over 4a. This will give us 4ac over 4a squared. Now we can bring the two fractions together. So we have b squared minus 4ac over 4a squared. Now notice that we can apply extracting square roots to our problem to write x plus b over 2a on the left side. And that'll be equal to the plus or minus the square root of that right side fraction. Now we know we can think of the square root of the numerator separate from the square root of the denominator, so we think of the problem like this. And in the denominator, the plus or minus square root of 4a squared will give us plus or minus 2, the absolute value of a. You see, the square root of the 4 gives 2. The square root of a squared gives absolute a. But plus or minus 2, the absolute value of a, is the same thing as 2a. Well, now we'd like to clear that b over 2a from the left side, so we'll subtract b over 2a from both sides. Now notice that we have a common denominator. Bringing the fractions together, we get our quadratic formula. The quadratic formula can be used on all of the different kinds of quadratic equations that we have had in the past. That is, even if a quadratic equation is factorable, the quadratic formula can be used to solve it. If it's unfactorable, the quadratic formula can be used to solve it. So all of the different kinds of quadratic equations that we've had in the past can be plugged into this quadratic formula for solution. That makes it a very general, a very widely used method for solving quadratic equations. Well, we're going to look at a few situations now. We're going to use the quadratic formula, but it's important to identify A, B, and C, those values to put into the formula. And I'd like for you to keep a couple of things in mind. There are three basic ideas that you want to follow every single time you use the formula. Number one, put the equation into the general form. That is, put all the terms on one side so that we can easily identify the value of A, B, and C. Now, in this problem, we would add 14 on both sides to give us this. Now we can easily identify the value of A, B, and C. A is the 1 here, the understood 1. B is the 9, and C is the 14. I hope I'm not confusing you here with these underlines. I'm not making fractions here. I'm just identifying A, B, and C. Now, generally, we wouldn't even write these. I'm going to leave them off for using the formula. In fact, we wouldn't write the 1 in here either. We just know where A, B, and C will occur in this form of a quadratic equation. All right, the next thing is, I said there were three things. One thing is to put the equation into this form. All right, the next thing is to write down the quadratic formula. Always just write it down without putting anything into it. So we'll write x equals minus b plus or minus the square root of b squared minus 4ac all over 2a. Now, it sounds complicated, but once you do this 2 or 3 times, it'll come to you very naturally. All right, the next thing is, and the third thing that's very important to keep in mind every single time you use this, is that in the next step, after writing down the formula, you replace letters with numbers. And that's all. Make no computations whatsoever. Replace letters with numbers. And it's really important to discipline yourself to do that, because you're going to cut down on a lot of mistakes by training yourself just to replace letters with numbers. Don't perform any computations. And it's going to be a temptation. There's going to be a temptation to do that, but resist it. All right, so in the next step, we're just going to replace letters with numbers. The value of b is the coefficient of the first degree term, so it's 9. So this is minus 9 plus or minus the square root of, now the b is squared here. The b value is 9, so we have 9 squared minus 4 times a. A is the coefficient of the x squared term, so it's 1. And then c is the constant, 14. And all of this is over 2a, which is 2 times 1. So we want to show that step. Now it's time to start to perform operations that are indicated here. So we have minus 9 plus or minus, and now most of our work is under the radical. 9 squared is 81. And then let's see, this is minus 4 times 14. That's 56. And all of this is over 2. And now 81 minus 56 turns out to be 25. Let's go up here. So we have minus 9 plus or minus the square root of 25 all over 2. The square root of 25 is 5. And now this represents our two answers. We have minus 9 plus 5 over 2 and minus 9 minus 5 over 2. We can split into those distinct two cases if we want to, or we can think our way through each one of them. But if we split into those two cases, it looks like this. Minus 9 plus 5 over 2 means minus 4 over 2 or negative 2. Minus 9 minus 5 over 2 means negative 14 over 2 or negative 7. Now, this particular problem was factorable from the beginning. We could have factored it into x plus 2 times x plus 7 and solved by factoring rather easily. But I think it's important to know that all kinds of quadratic equations can be solved using the quadratic formula. Here's another one. Now here we would begin by rewriting in a form where we can identify A, B, and C. Now it wouldn't make any difference here if I had decided to put the 4x squared over there. That is, subtract 4x squared on both sides, and then I would have minus 4x squared on the right and 0 on the left. That would be perfectly all right. I can use an A value that's negative. That's no problem. But I elected to put the 4x minus 1 to eliminate these by subtracting 4x and adding 1 on both sides. But either way is okay. All right, now once I'm in this form, I can now apply the quadratic formula. Here's the formula, and in the next step, I just replace letters with numbers. Now it's important to realize that this is A, that's B, and this is C. Now notice the b value is negative, and it presents us with some situations that are important to take care of. This minus b means the negative of, or the opposite of, whatever b is. B is itself negative. So this is the opposite of a negative number. It causes us to have to introduce a parenthesis. So here, this is the minus whatever b is, and b is negative. You see, so we introduce the parenthesis to separate those minus signs. All right, so it's minus negative 4 plus or minus the square root of, now b is squared. B is a negative number. So again, parenthesis to contain that negative value. Negative 4 is squared minus 4ac. Now the a value is 4 from up here, and then the c value is 1 from up here. All right, and in the denominator, 2a means 2 times 4. And now we go through and perform indicated operations. The opposite of negative 4 is 4. Negative 4 all squared is 16. 4 times 4 is 16 times 1 is 16. So this is minus 16. And lo and behold, we have 16 minus 16 under the radical, so we really have the square root of 0. And the square root of 0 is 0, so this entire term goes out, so we have 4 over 8, or 1/2, for the value of x. Now notice there that only one value is coming out of this. Only one solution, or one root, is occurring for this quadratic equation. Sometimes that situation happens. It's a double root now. It actually occurs twice. If we were factoring, it would turn out that the factors would be x minus 1/2 times x minus 1/2. But at any rate, this double root idea is a possibility, and we can see it here with using the quadratic formula. All right, here's another one. Here's our quadratic equation. We can easily identify a, b, and c when we're in this form. We write down the quadratic formula and we plug into it. Now minus b means the negative of, or the opposite of, the b value, which is negative 4. And once again, we need to introduce the parenthesis to contain that negative. And then b squared is negative 4 all squared minus 4 times a times c. The a is from up here, and the c is the constant term. And then all of this is over 2a, which is 2 times 1. All right, now we go through and perform operations. The opposite of negative 4 is 4. Negative 4 all squared is 16. 4 times 13 is 52, so this is minus 52. And under the radical, 16 minus 52 is negative 36. The negative under the radical tells us that we're going to have an I form, an imaginary value, and the square root of the 36 is 6. So this part is the 6i. So we have 4 plus or minus 6i over 2. The 2 divides both parts of the numerator, so this is 2 plus or minus 3i. Our two solutions. Now notice 2 plus 3i, 2 minus 3i are our two solutions, or they're called roots to our original equation. And if we put these values into the original equation, we would indeed see that we have truth. Well, we've noticed now, we've encountered several different kinds of answers in our problems. And it turns out that those kinds of answers, whether the answers are real numbers or integers, whether we have a single root or whether we have complex roots, that is, when I say complex, I mean purely complex, those roots that have an imaginary part in which the b value in the a plus bi form, where the b value is not equal to 0. But we've had all of those different kinds of things. And, you know, we could actually pick off when we have that occurrence. Now, let's back up here just a little bit. Here, well, let's stay right here just for a second. 16 minus 52, when we ended up with this negative value under the radical, we could have known at that point that we were going to get the complex solutions. Back here, when we found that we had the square root of 0, you see the value under the radical was 0, we should have known that we would have plus or minus nothing, and we would simply have the fraction composed of, you see, this negative b over 2a, you see. And if our coefficients and constants are all integers, then this is just going to be a rational number every single time. And back over here, we had the number under the radical was 81 minus 56, which turned out to be a square. But as long as it's a positive number, we're going to get real numbered answers, and if it happens to be a positive square, then those answers are going to end up being integers. Or, well, rational numbers, because they could end up being fractions because of this. But so that number under the radical turns out to be a very important number in terms of identifying the kind of answers we're going to get. And it's for that reason that that number under the radical is called the discriminant. The discriminant. It discriminates among the different kinds of answers we can get. The discriminant is the number under the radical. Now, no radical sign here. The discriminant is the b squared minus 4ac part of the quadratic formula. And we just decided that if b squared minus 4ac is equal to 0, that is, that radical part goes out altogether, then we have one rational root, one rational solution. Now, it's a double root, it's a double solution, but nonetheless, it's only one distinct number for our solution. If the discriminant is less than 0, if it's negative, we have a negative number under the radical, gee, that gives us an imaginary value, well, we get two complex solutions, or roots. If the discriminant is positive, then we get two real numbered roots, and if it's a positive square, we get those roots happen to be rational numbers. So we can tell a great deal about the situation just by looking at the discriminant. We can, when we just first see, well, let me show you what I mean. When we first see a quadratic equation like this one, and we'd like to know what kinds of solutions we're going to get, we can analyze the situation just by doing this, just by calculating b squared minus 4ac. Just determine the value of the discriminant. So b squared, well, that would be minus 4 squared. Minus 4 times a is 1 times c, 13. Now this is 16 minus 4 times 13 is 52. And so 16 minus 52 is negative 36. Aha, a negative number. And that tells us then that we are going to get, as a result of this, two complex solutions to that quadratic equation.